So in this video, we will discuss about the tension acting through the ropes. That is, let's take two bodies. Let's say we have two masses. This must be M1 and another mass M2. Both these masses are connected by ropes. Suppose if I give a force, let's say some force F to the right hand side, that is to the mass M2, we need to find the tension acting in the ropes. Here this region, these two bodies are connected using a rope. Here also we have a rope. So how will we find this? Let us consider the acceleration first. When I apply a force to the right, both these bodies have same acceleration. Can you think why it is so? Because both of these masses are connected and we cannot say one body move with a different velocity from the other. Both these bodies have same velocity because they are connected. So this region is the rope, and we are interested in finding the tension acting through the rope. So the first point is always the acceleration remains the same for both the bodies. Now see, for a rope, you have to always note this. For a rope, the tension is always pulling in nature. That is, it always pulls the body. Clear? So if I apply a force in here towards right, a tension is acting in this direction. Let's say that is T. One more point, we always consider an inextensive rope. That is, the rope cannot be elongated. So in order to balance this tension, there will be a tension in the opposite direction too. See, for example, I'm taking this region. If there is a tension acting in this direction, a point in here, let's say A, is moved towards left. So to balance this T, we should have a tension in the right direction also, so that these two will cancel each other and the rope is not elongated. Clear? Now we need to find the value of tension in terms of A, M1 and M2. For that, let us consider the free body diagram. FBD means the free body diagram of the mass M1, of the mass M1. Let me draw its free body diagram. We have mass M1. We have acceleration towards right, and the force acting on the M1 is only T. And from the Newton's law, we have unbalanced force. This is very important. Unbalanced force is always mass into acceleration. This is a statement from the Newton's law, that is, unbalanced force is equal to mass into acceleration. So what is the unbalanced force in here? There is only one force, that is T. So we can write T is equal to mass, here it is M1 into A. Let's put that as equation number 1. Now let's consider the free body diagram of mass M2. Let me draw the mass M2. So this is our mass M2. Here there are two forces, that is a force F towards right and the tension T towards the left. And acceleration is also towards the right. Acceleration like in the mass M1, here also it is towards right. And we can again apply this formula, unbalanced force equal to mass into acceleration. So what is the unbalanced force here? Here the body is moving towards right, so this one will be greater. So unbalanced force is equal to F minus towards the left, the force will be taken as negative, that is F minus T is equal to mass is m2 into A. So this gives the equation F minus let's say m2A is equal to T. Call this as equation number 2. Clear? When you compare 1 and 2, let's say from 1 and 2, both these equations are the same because both these give the tension T. So we can write F minus, we have equation 2 is equal to equation 1. That implies F minus m2A is equal to m1A. Or you can write F is equal to m1A plus m2A. F is equal to, you can take the acceleration as common m1 plus m2. This gives acceleration A is equal to F upon m1 plus m2. Clear? So this is the expression for acceleration, and you can put the value of acceleration in the equation 1. That is, we have that is in this equation, if you put this value, we have T is equal to m1 into A. Instead of A, you can write F divided by m1 plus m2. Clear? So we have acceleration A is equal to F by m1 plus m2 and tension T is equal to m1F by m1 plus m2. Let me write it here so that we can do a problem. Now let us consider a problem. Suppose we have two masses, let's say some 3 kilogram mass and a 2 kilogram mass. Both these masses are connected using an inextensible rope, and it is pulled towards left with a force, let's say some 60 Newton force. Now we can we can find the tension. Now let's draw the direction of tension. T will be acting like this. Acceleration is towards the right like this. Now you can use the equation. We have acceleration A is equal to F divided by m1 plus m2. Here F is 60 divided by m. Here m1 is equal to 3 kilogram. m2 is equal to 2 kilogram. So 60 by 3 plus 2, which is equal to 60 divided by 5, which is equal to 12 meter per second square. So the acceleration is 12 meter per second square. Now what about the tension? Tension T is equal to m1F by m1 plus m2. That is 3 into F is 60 divided by 3 plus 2, which is equal to 3 into 60 divided by 5. Cancel this, 12. So 3 into 12 is 36 Newton. So the tension in the rope T is equal to 36 Newton. Clear? So for a two mass system connected using a rope, this is the expression for acceleration and this one is the expression for tension. Now what happens if we connect three masses using the ropes like we did here? That is, when we have three masses, let's say we have a mass m1, another mass m2, another mass m3. These masses are connected by ropes like this and is pulled with a force F towards right, like we did before. Now, if we draw the free body diagram, first the tension acting on this rope will be like this, T1. Remember, tension is always pulling, so it pulls the body to here. Here we have to write T1 and T2 because there will be two tensions because we have two ropes. Here the tension will be T2. To balance this one, we have a T2 towards right also. As we said before, acceleration of all the bodies is the same since they are connected to each other. Okay. Now, as our first step, consider the free body diagram of mass. Let's take the mass m1. If I draw the mass m1, we have a tension T2 towards right and an acceleration A. Now we have, again, let me write that equation. Unbalanced force is equal to mass of the body into acceleration. So this is the equation from the Newton's law. Unbalanced force is always mass into acceleration. So here there is only one unbalanced force, that is T2 equal to mass of the body m1 into A. Let's put that as equation number 1. Now for the mass m2, that is for mass, let's say m2, for mass m2, when I draw the free body diagram, this is our mass m2. Here it is there is a force towards left, that is tension T2, and there is a force towards right, T1, and the body is accelerating towards the right. Again, if I use this equation, unbalanced force equal to mass into acceleration, here the body is moving towards right. So T1 is greater than T2. So unbalanced force is equal to T1 minus T2. All the forces towards left is taken as negative and that towards right is taken as positive. So this is the unbalanced force equal to mass of the body m2 into acceleration. Or you can write T1, this gives T1 minus m2a is equal to, let's say, T2. Put that as equation number 2. Now, finally, take the free body diagram of mass m3. For mass m3, we have, this is m3. There is a force T1 towards left and there is a force F towards right. Again, the acceleration is A towards right. So the unbalanced force in here is F minus T1 is equal to m3 into A. Let's call this as equation number, let's say 3. Now you can use the equation 1, 2 and 3 to find an expression for acceleration. Let me erase this. From 1 and 2, that is from these two equations, we have both this equation gives the value of T2. On the one side it is T2, so we have T1 minus M2A is equal to M1A, which gives T1 is equal to M1A plus M2A. Call this as equation number 4. Now put this equation 4 in the third equation. That is F minus, instead of T1 you can put this value, that is M1A plus M2A is equal to M3A. Taking this whole term towards right, you will get F is equal to M1A plus M2A plus M3A, or F is equal to A into M1 plus M2 plus M3. Therefore, acceleration A is equal to F divided by M1 plus M2 plus M3. Clear? Now, if I put the value in this equation number 1, then I'll get T2 is equal to M1 into A is, we have F divided by M1 plus M2 plus M3. This is our tension T2. Now we have T1 is equal to, here T1 is equal to T2 plus M2A, taking this to the right. Therefore, T2 we already found out, M1F by M1 plus M2 plus M3 plus M2 into acceleration is A is this one, F by M1 plus M2 plus M3. Here the denominator is the same, so you can write M1 plus M2 plus M3. You only need to add the numerator, and again you can take the F outside, so M1 plus M2 times F. So this is the value of T1. Let us consider an example. Suppose we have 3 masses. Let's say some 2 kilogram mass, 3 kilogram mass, and let's say some 5 kilogram mass. All these masses are pulled with a force of 60 Newton, and we need to find the T1 and T2. We took T1 here and T2 here. Now we have, first find the acceleration. Acceleration A is equal to F, that is 60 divided by M1 is this one, M2 is this mass, M3 is this mass. So 2 plus 3 plus 5, which is equal to 60 by 10, which is equal to 6 meter per second square. Now we need to find the tension T1. T1 is equal to M1 plus M2, that is 2 plus 3. 2 plus 3 times the force F is 60 divided by the total mass, that is 2 plus 3 plus 5, which is equal to 5 into 60 divided by 10, which is equal to 30 Newton. So tension in this rope is 30 Newton. Now the final tension T2, which is equal to M1F, that is 2 into 60 divided by 2 plus 3 plus 5, which is equal to 2 into 60 divided by 10. That is equal to 12 Newton. Clear?